a fish that memorizes the smell of its birth stream as a baby, then crosses an entire ocean to find it again years later, just to lay eggs and die. Every year, millions of Pacific salmon leave the ocean and swim upstream. They fight against rushing currents, leap over waterfalls, and push their bodies past the point of exhaustion. They do not eat during the entire journey. Their muscles deteriorate, their skin turns red, and their jaws deform. At the end of this grueling trip, they spawn in the same gravel bed where they were born. And then they die? It is one of the most dramatic one-way journeys in the animal kingdom. And the navigation system that makes it possible is almost entirely based on smell. Salmon are born in freshwater streams and rivers, often hundreds of miles from the ocean. Within weeks of hatching, juvenile salmon undergo a process called imprinting. Their brains chemically record the unique scent profile of their birth stream. Every waterway has a distinct chemical signature created by the minerals, soil, vegetation, and organisms in it. The young salmon memorize this scent at a molecular level. They carry this olfactory memory for their entire ocean phase, which can last 1 to 5 years. When they are ready to spawn, this stored scent becomes their primary navigation tool for the final leg of the journey. The ocean phase of a salmon's life covers thousands of miles. Pacific salmon travel from rivers in Alaska, Canada, and the Pacific Northwest all the way to feeding grounds near Japan and the Aleutian Islands. Scientists tracked one Chinook salmon that traveled 3,100 miles across the Pacific. For open ocean navigation, salmon do not rely on smell. Instead, they use the Earth's magnetic field. Their brains contain magnetite crystals, tiny biological compasses that detect magnetic field lines. This gives them a rough directional sense, like a built-in GPS. But magnetic navigation only gets them to the right coastline. The final precision comes from their nose. When salmon reach the coast, they switch from magnetic navigation to olfactory navigation. They literally sniff their way home. As they enter freshwater, they detect the chemical signatures of each tributary. At every fork in the river, they choose the branch that smells more like their birth stream. Experiments have proven this conclusively. When researchers plugged the nostrils of migrating salmon, the fish became lost and swam into random tributaries. When the plugs were removed, the salmon corrected course. The precision is extraordinary. Salmon can detect their home stream's chemical signature at concentrations as low as 1 part per billion. That is like detecting a single drop of water in an Olympic swimming pool. The death of salmon after spawning is not a failure. It is a biological design. Pacific salmon are semmelporous, meaning they reproduce only once and then die. Their bodies are programmed to self-destruct. Cortisol levels spike to 10 times normal, causing organ failure. But their death feeds the ecosystem. A single salmon carcass delivers ocean-derived nitrogen and phosphorus to the stream. Bears, eagles, and dozens of other species depend on this nutrient transfer. Trees growing near salmon streams grow up to 3 times faster than those further away. The salmon's death is actually an investment. Their decomposing bodies fertilize the very stream where their offspring will hatch. If you found this fascinating, subscribe to Curious Science. Next time, we are exploring whether breakfast really is the most important meal of the day.